It's a Thursday afternoon and I'm just getting home from school. My oldest sister is already calling dibs on the TV for a new episode of Friends. My other sister is at the computer playing Mind Maze on Encarta 95. And I'm patiently waiting for Mom to take me to the mall so I can empty my savings account on a brand new Nintendo Virtual Boy. Once back home, I quickly set up the system, and using scan linear array technology, I was transported into Wario's world of greedy treasure hunting, and I was hitting the court for some friendly tennis matches. But once the novelty wore off, the uncomfortable system that left my eyes hurting after just 30 minutes of playtime had lost most of its appeal. On top of that, the N64 came out 1 year later, and I had some real buyer's remorse for not holding out for that legendary console. But anyways, getting to the point here, there's long been an interest in extended reality, but not until recently has it really hit a sweet spot for form and function. The AR Alliance knows this and knows it's time to capitalize. Their mission is to provide a supportive and neutral environment for organizations to collaborate and to help advance the augmented reality ecosystem. AR, VR, and MR technologies can assist in virtual communication, training, entertainment, and so much more. And on top of the applications they can cover, new hardware is constantly improving to become safer, more comfortable, and readily available. SPIE appreciates the significance of this industry. The society hosts its own AR, VR, MR Expo every year within Photonics West. And it was at this year's event that we got the chance to gather 6 industry leaders from around the world in person to discuss the future of this market, the emerging tech driving innovation, and the importance of collaboration. In this very special episode of All Things Photonics, and with the assistance of the AR Alliance and SPIE, we're bringing to the table Stefan Bellasguardo, VP of Global Product Marketing with Luminous Devices, a developer of solid-state lighting solutions, Brian Chen, General Manager of Apotronics, a company with a focus on laser display technology, Theo Moresco, founder and CPO of Swave, a fabless semiconductor company, Jor Grieterer, CTO of Trilight Technologies, a designer of small projection displays, Robert Schultz, Vice President of Optics at Vuzix, a provider of optical products for AR systems, and Barry Silverstein, Director of the Center for Extended Reality at the University of Rochester and former Chief Technology Officer and Senior Director of Optics and Display Products at Meta Reality Labs. All of our guests have a unique background with differing areas of expertise, and they're all sharing their insights on the XR market and the technology at its core on this episode of All Things Photonics.
Today's episode is brought to you by Hamamatsu Corporation, a leading manufacturer of devices for the generation and measurement of infrared, visible, UV light, and X-rays. Hamamatsu is dedicated to the advancement of photonics through extensive research and offers specialized systems for select applications. Visit hamamatsu.com to learn more.
From Photonics Media, this is All Things Photonics, a podcast where we explore industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, we'll speak with some of the brightest minds in industry and research about the trends shaping the landscape of photonics.
Getting into it, gentlemen, XR tech at one time felt kind of like science fiction, but now headsets are commonplace, and advancements making it smaller, more energy efficient, and even more immersive. So the next generation of smart glasses and head-mounted displays, they're going to be on the exhibition floor downstairs. And I want to start with you, Barry. Can you tell me what we are expecting to see in terms of advancements in this tech?
Yeah, so the technology for AR and VR, XR in general, has been advancing rapidly as companies like Meta and Apple have started to put products into the market, but more so as AI has developed as a fantastic interface to be in conjunction with AR, or really what I'll call smart glasses. So what you're going to see, for the most part, is advances in the smart glasses category, and then the technologies that will be introduced in the next a couple years, which supports this smart glasses vision, but also the next technologies beyond that, which will improve upon it. And that's what brings us here today, which is to introduce and discuss laser display for AR. Because I think laser display will have a strong position in the market eventually, and it inevitably lead to the best AR display systems that we want in the future. And the goal of this group here is to bring that future to people as fast as possible.
Very exciting. And Brian, I want to turn to you. What do you think we're expecting to see? What are the big advancements you're excited about at this Expo?
All right. So I just came from CES to here at the SPIE, and seeing a lot of brands and players going into the market with the smart glasses. And you do see a lot of different technologies coming out. It's very interesting from shifting from CES to SPIE, because at CES I just see a lot of brands, glasses, designs, and in here I see a lot of technology behind the scene, which is supporting the advancement of AR glasses. And it's an interesting thing to see the market and the technology thrive at the same time. And I think for now, the technology for display in AR is moving along. I think laser will play a major part along the way, because we do a lot of laser specking projections, and I think laser will extend the ability of the AR display in the future, and I think it's quite soon as well.
The smart glasses, they have a small field of view, right? But they're using LED illuminated liquid crystal on silicon now, and some groups looking towards micro LED imagers. What are the advantages here, and what role are lasers going to play in this switch?
Well, I think today you see a lot of people pushing products with technologies they can implement and their solutions, because the display is super important, right? But they need to start with productizable solutions, and so we have been a player in that space. We are actually, for multiple years, we have been delivering LED solutions for this space. I think it's clear there is a massive wave of investment, and people start to think long term. So for us, as an opto license supplier, we see that the laser technology is bringing a lot of the same attributes we have seen lasers bringing to the general projection market in other applications, in their size, efficiency. So we as a license supplier, I would say we are not going to say make a bet, but we believe that the laser are going to be a very important technology. We are in LEDs. Our parent company is in micro LEDs, but we believe lasers cannot really be overlooked, because there are definitely the clear advantages technology bring that will be needed as the market matures to enable some unique performance, form factor, or capabilities.
Very exciting. Anyone else want to weigh into on the impact lasers are going to have, we think, in this, emerging field? Robert?
Just one thought is that it's not edge cases under which AR fails at times. Brightness, being able to go outside, compete with the environment, battery life, some things like that, wider field of view. These are things that are the ability to, from working with diffractive waveguides, to be able to compensate for color performance and that kind of thing, to have the bit depth you might need or within the image characteristics. These are all advantages that laser brings to the table. And that's, I'm generally display agnostic, but I see lasers as playing a key component in, bringing this entire industry, across the finish line to where it needs to be.
If you're looking at the market, the driver is really AI, and you want to be able to wear these devices the entire day. Right? So you need the devices to be comfortable. You have to be able to display the information with a natural accommodation. You want these devices to be fashionable. Right? So that means that they're lightweight, and you want them to be compatible with prescription. And it's really our view that you need to break the physics barriers of some of the technologies today, and lasers are uniquely positioned for that, because that also allows, I would say, alternative projection engines that can get past these barriers that are affecting the form factor.
And I want to take the second now to thank the AR Alliance for helping us organize this conversation, because it's such a special thing, I think, to have so many, experts in this industry, leaders of their companies joining together to talk about this. And, exciting to see too that the AR Alliance became a division of SPIE just a couple months ago. Another example of their kind of rise in this industry. And within this division is the laser display for AR group. Barry, you were a big part in creating that. Can you tell me kind of what the group's mission is?
Yeah. So the mission basically stems from the need for industry in general to realize that AR has a place in this solution space. There are many fragmented efforts, or there were many fragmented efforts going on that didn't necessarily provide enough confidence that laser could be the great answer. And and so pulling together the different companies and the different academic institutions to create this entity is a way to conquer that problem. Um, there's a kind of a quote that I use: just because no one's asking doesn't mean no one cares. Okay, so essentially, this organization is defined to ask the question so that people can see what lasers can deliver, so that they can care. But as others had said today, is that the immediate thing for the larger companies is to deliver products that they can deliver today, rather than address all of the technologies for the future. This group needs to address the readiness of lasers for AR, to get a position in the AR space.
Well, very interesting. And Jorg, I want to bring you in on this. How, is your company positioning itself to embrace, all the advancements here to bring lasers into this and kind of help push AR into this, next step?
So with TriLED, we are building so-called laser beam scanners. So this is also a laser-based display engine, and it consists of 3 lasers in typically red, green, and blue colors. And then you have a scanning micromirror. This is the architecture of display that we develop. And we have for a long time shared Barry's vision that the AR display market comes in certain waves. So the first wave is liquid crystalline silicon, LCOS displays, which hit the market already. Ray-Ban Meta display glasses have been out now since a couple of months with that type of display. And the second wave will eventually be micro LED displays. Yeah, and the third, and we strongly believe ultimate wave will be laser displays. And this is stemming from the fact that this has some fundamental physical advantages. So laser light has different properties compared to LED-based light sources. So it has a narrow bandwidth, for example, is inherently polarized light. It has a smaller so-called étendue, making it possible to make light sources or light engines smaller compared to LED-based engines. So we strongly believe this is the way forward. Yeah, and we are happy to be in on the ride here.
Fantastic. And, and I always appreciate too when for these podcasts that our audience has a very good, knowledge of the inner workings of photonics. But not everyone is so well versed in this particular field as it, continues to grow and evolve and emerge. Is there anyone who would like to take the task to help me kind of chart the evolution of AR display tech and maybe help explain why now is the right time to launch this new focused effort to advance this field?
Yeah. So the history goes back a really long time, decades, in fact, but I won't go back that far. So the initiator was certainly Google Glass for the AR space, not for the XR space, but for the AR space, where they built an engine that fit pretty much on the outside of glasses to provide basic information to wearers. That got a lot of pushback, and it got a lot of pushback because the glasses were definitely visible. It was easy to see when someone was wearing Google Glass. It was limited in the number of people who could get it, and it got a bad reputation. Additionally, there wasn't a whole lot you could do with it yet because the interface was a challenge. And so, along came VR with Oculus, generating a headset that started to combine functionality that was useful through gaming. And this was by combining essentially cell phone technologies and then continuously improving on them. And of course, in the background, there was advancements of AI. Okay, and AI was believed to be a necessary feature for smart glasses, so that you'd have an interface that wouldn't be cumbersome. Okay, being able to talk to your glasses or interface in a way that could be managed and incredibly useful. But ultimately, the answer for the progress has been driven by Meta, which started with simple smart glasses without a display, that looked like regular glasses with cameras and audio, that were both good enough to get people interested. At least the second version was good enough to get people interested. And then when with the addition of AI on the second version, now there was an interface that was both cool and useful that you could manage. And then the first display just got introduced with a relatively basic display, 20-degree field of view, with an LCOS solution, which is what was really available to give a quality experience, but it's only in a monocular eye. But the demand for that has been very high, and the interaction with AI has been driving interest for usability, and you're gonna start to see many more companies move forward in terms of delivering a similar type of pair of glasses with displays. The displays will eventually move to binocular as the weight comes down for the display system, and the field of view will open up, and the interfaces will get stronger and stronger. So you'll see a significant growth from here on in.
Yeah, I think so. And I want to talk, the growth of a lot of the applications that are kind of driving this and kind of ask, what type of laser-based displays can this working group support? And what are the applications that, we're expecting to see benefit from the work done here? We mentioned gaming, but I think there's a myriad of ways between research and medical. Is there anyone who would like to kind of talk to me about some of the applications we really see benefiting from this, where it's, out of the research, it's in practice?
I'll start with that. And so also, because I'm from China, so I'm back in China, so I see a huge shift in museums. Actually, is an area that no one expects. We always have the audio guides, right, in the museum to listen to them and go through them, but it's tedious, right, because the explanation is so long. Introduction, you can see a lot of items and you skip them. But I see a huge shift in China that people are wearing AR glasses instead of audio guide, because it's much simpler to do that, and the audio is quite private, and you see the items and then it's categorized and it shows you can actually zoom in or out using gesture recognition on the AR glass. But it's not like the type of glasses we wear daily. It has a cable extending, right, because the power consumption is, and the AR calculation power you need is actually bigger than itself. So, but you see those shifts, and people actually in China love them, and they use the pairs of AR glasses used in museums are increasing exponentially every year. So I think maybe in 2 or 3 years later, all of the museums in China will have AR glasses replacing the audio guides. So that's just one type of area that AR glass might be functional right now. And I think there will be a lot more applications coming on because of the AR evolving. And I think several companies back in China is targeting about the payment method using AR glasses and biometric security along with display to show people how AR glass can function instead of using a phone to tap on and scan a code or things like that. So I think it's changing people's way to interact with the world. So there will be a lot of specific areas popping out first, and then later it will become consumer products like the phones. That's what at least what I see now.
Your use case is very interesting because it's very specific and very grounded and very real. And, we've spent a bit of time focusing on the industrial market and trying to be useful to what people can have. So people that are going to find it saturating their lives in other ways, warehouse workers or, movie theaters have used them for accommodations and, museums but then, medical and, warehouse picking. I mean, there's just so many places where they're going to start coming in. And then the AI on top of that, with the consumers using it to replace their phones to, it's achieving a level of acceptance that wasn't there when Google was first, introduced. I think that we're getting past that kind of, my God, you're recording me kind of paranoia, because everybody's got 3 or 4 phones on them at a time now, or 3 or 4 cameras on them at a time now, it seems. But the acceptance level has crossed that threshold, I think. And I think that the other side is that people's expectations are getting closer to reality, in the sense that back in the day, I remember, Lawnmower Man, or well before the some of those other things. You go back to some of these early AR things, people would try on a pair of glasses and they'd be like, "Is this it?" And they'd be completely disappointed. Now they're putting things on and their realizations are somewhat, reset, and they realize the challenges that are involved in actually presenting that full experience. And I think we're finally starting to rise to meet some of those challenges, and the laser scanning is definitely part of that, particularly when you're outside and trying to get all day battery life and that kind of thing. But
yeah, it sounds, like those things you told someone, decades ago, you're going to have a phone in your pocket all the time. Maybe they wouldn't believe you. And now it's a computer. Now it does everything. And, how far are we realistically from AR being so ubiquitous, where it's just kind of assumed that your glasses must have some sort of AR in it? It's just kind of assumed that, it's like using an abacus instead of a calculator, So is that like realistic to think with, before too long, that this should be so standard that we would see it virtually everywhere?
Yeah, I mean, I think there's a platform shift. Actually, there are 2 platform shifts happening at this point in time. I mean, if you look in the past, when we moved from web to mobile, it was the shift to mobile, and you had applications like mobile search and mobile advertising. And now you have the shift to, AR glasses. So you get, new applications that we don't have yet, like visual search or potentially visual advertising. But really the important driver on top of that is AI. We all are going to get our personalized AI agents, and you want to interact with them in a natural way, right? And your visual system is the main way to get information in. Now, that puts requirements on the product. The product has to be like real glasses, and it has to be compatible with prescription glasses.
And I think we saw at a CES too some news coming out with some AR glasses meeting a prescription need. So probably not too unrealistic to think that we're getting there.
Well, yeah. So Meta has the ability to put prescriptions in their display, but I want to double down on the difference between audio and display. So one of the prime examples that we all would like, especially the folks that are from other countries, would like, is translation. So smart glasses with translation are out there, and the regular Meta Ray-Bans, for example, already have them in it. But having audio when someone is talking to you, having another audio channel in your ear that is a different language, and trying to manage that and distinguish what the person is saying and what you're hearing in your ear at the same time is not something our brains are well attuned to do. And so you'll lose a lot. But a display can be persistent until you've read it, especially if you have eye trackers in it. Which can follow your eyes and say you've read it and then listen for you actually speaking back and responding to it. The AI can fully manage this, and you can really have a solid translation in any language when the latency on that is low enough, and the displays are good enough. So, and that's coming very rapidly.
And if I could maybe double click on that, if you want to have, real-time translations and captions, the specificity of laser displays is that you can put that, those closed captions at the correct depth. If we're having a conversation, I need to have the translation, the subtitles at the same level where you are. I need to be able to, look at you and read the subtitles at the same level. I can't have my subtitles here and then speaking with you at the same time. And this is a unique thing that laser displays, or certain laser-based displays, can enable.
Yeah, for folks who haven't understood what that is, this is what's called conquering the divergence accommodation mismatch, which is to be able to put the focal plane of the display in the right display in the right location in the real world. And if you can't put digital objects into the right location in the real world, you have an information display, but you don't have really AR.
Interesting. And I liken it to, everyone's watching TV with closed captions, but your TV is against the wall. If it's right here, that's not helping you, right? So you want to match up the plane. I'm taking a wider look at display technology. We have liquid crystal on silicon, laser beam scanning, holographic displays, and nonlinear emissive displays. Is it possible to pick one of these and say, this is the best, we should be devoting our research here? Or are we, still exploring the strengths and weaknesses, and maybe we find areas where one shines brighter than the other and kind of, vice versa?
That's a touchy one.
We are all part of the laser display for AR working group, right? So all of us strongly believe in laser displays being the future of AR. And coming back to the different waves of display technologies that we are seeing already today, and that we all jointly believe that the market is headed, it will be laser-based, based on fundamental properties of laser light, including efficiency. So if you talk about all-day wearable glasses, you need to fulfill very strict requirements, right, on the system level. So the glasses must not weigh more than, let's say, 50 grams, right? And that gives a very strict limitation on the display engine itself in terms of size, weight, power consumption, ultimately cost as well. And I strongly believe laser displays will win the race. As of today, there are clearly other competing technologies in the market. And I think right now, all of these are coexisting for some time.
Yeah, I think there are different technologies to address that. The way I like to think about it is that I want to replace bulky optics and heavy optics that are bending rays with a computational display. Because the computational display will allow you to remove the weight and reduce the volume and do things dynamically. So, like for instance, like natural accommodation. And there are multiple technologies to address that. That's why we're doing holography. Trilight is doing laser beam scanning. So they all have their pros and cons.
Interesting. Yeah, and I think that's a lot of different ways to skin a cat, so to speak, right? But there's going to be different applications where something might shine over the other. Robert, please.
I was saying the hatred for cats. No, I'm kidding. It doesn't take anything away from the other technologies to support laser scanning. I mean, laser scanning, even within the laser scanning community, you've got laser displays, holographic displays, you got direct emitted kind of variants of laser with different levels of coherence to them. You've got, laser illuminated LCOSs, and you've got full scanning systems. I think that lasers clearly play a part in the way that the technology is evolving and where it needs to go. And I think that, certainly, in the immediate future, there's some definite advantages and places we can get that we can't get to otherwise. And in terms of, competing outside brightness and wide field of view and some of those kind of solution sets, I think that this is the best opportunity to get there.
Talking about some of the, we talked about the applications and what we're seeing AR, VR being used now. And, we've long seen this technology turn the corner from kind of a niche tech to something more mainstream. But are there still barriers out there that are hindering kind of its full potential in terms of commercialization? And how are we addressing these?
Well, I don't know. From what we have seen people getting in that space, aiming for the consumer and backtracking to go back into use this medical industry application that are really more like head-up displays. Probably the usability, the seamless aspect. I mean, the quality of the display can be a factor, but all of this is probably what is kind of it's complicated right now to use these devices. And as we cross, with integration of more sensors and intelligence and, predictive views, where it's more intuitive and, almost passive to use these devices, I think that's where we'll start to see the real, application drivers. I expect it will be in a number of areas we don't imagine today. I think it might be embedded in not only glasses, but also, host devices, whatever, helmets for motorcycle riders. I'm one. And so I think that's little bit of the to me is the challenge to see really, it's not a gadget. If it's a gadget and it's, you have to be a techie to use it, and it doesn't serve a purpose, I think that's going to be limiting the success. Now, with this in mind, back branching a little bit still on the previous question, I think it would be pretentious to name a technology. It's clear that probably you need multiple technologies because they'll have differentiation. People will make sure they do. People will not want to be all based on the same engine. But the laser displays clearly are going to come with unique attributes that are going to be extremely valuable in the ability, the size, the coming also with low power, ability to go in some technology with large field of views. I think there's a lot of different approaches here that come with. If they can go mainstream, be very good for the end users, both in consumers and professional fields.
And it's a very clear lasers are going to play a big role in display advancement. And with lasers, there's always a safety concern. Is there any concern that comes with that in these applications or in this process that, just that we need to address or we need to be careful about?
Yeah. So the answer is you need to be careful with any product that you introduce. So whether it's lasers or a high powered LED, light is light, and sound is sound, right? The audio levels of sound, your people are using these things. You need to be very careful in making sure what you're doing is safe. That said, it's surprisingly low amount of light that's required to make a good display in someone's eye, and as such, inherently, the laser systems, our laser display systems, are as safe as the scanner that you already have in your supermarket. What I would say is that there is perception that needs to be overcome because it'll make people nervous wearing lasers. It may make people nervous wearing lasers on their heads, but we've conquered these things before. The best projectors, the brightest projectors in the world are in fact laser displays. They're out there in the market and are working safely. And I worked on that, and I believe firmly that this is no more challenging than that. And it's you have to do your proper performance assessments and get approvals, but mostly you have to get consumers comfortable with the idea that what you're introducing is safe.
Yeah, I think there's such an eagerness for AR and VR systems. It feels like consumers are more willing to say, you say it's good? All right, I want AR, VR, so I want to dive in. So there's kind of that excitement about getting into these.
Yeah, you shouldn't actually know that it's lasers. Or need to know that it's lasers as a consumer, right? So that unless someone decides to market it that way, as an advantage, which it will be, but otherwise, there are lots of products that we use every day that have lasers in them, and it's you. In order to sell it, you have to make it safe, and so perception is going to be the hardest challenge.
The idea of intentionality within the design structure to make sure that they're inherently safe is a huge part of it. And as long as that's in the regulation, the first time somebody gets hurt, there's major blowback and a major concern, and then it shuts everything down. So nobody wants that. Everybody wants the regulation, the safety things in place up front. And, as Barry said, lasers are everywhere. They're understood. It's not a new technology anymore. So from that perspective, we know exactly what the thresholds are for the eye and that kind of thing. And designing around that is just, it's just an engineering problem at this point.
It's more safe than laser pointers that you can buy.
That's true. That's very true.
Yeah. I'm glad to hear that because my son has gotten me in the eye with a laser pointer before. I'm like, that can't be good, but I was all right. And it's so refreshing to have so many minds from so many great companies here at the table. And, businesses are by nature competitive. It's the nature of business, but I've always been so impressed with photonics in general that there's this collaboration and there's this ability still to come together for a general cause or push. So, what roles do these groups play in the AR Alliance, and how important is it to have that kind of cooperation and collaboration when businesses could very easily be competing?
I think this is the beginning of a new ecosystem. We want to break through, some physics barriers, but the technology to do that requires that we just work together.
It's just that simple. Theo, one when we all strive, the industry strives, right?
That's right.
Fantastic. Anyone else want to weigh in on how, important this kind of cooperation is to just, put aside competitiveness and say, we all succeed together?
Barry mentioned earlier when the Google Glass first came out, and at the time we were, delivering products and things that would be competitive to that space even up to then. But the Google Glass was such a large announcement, and it was really a good thing. I mean, the rising tides raise all ships kind of a mentality that, that everybody working together to get a good solution will help us all. And if we all go into our little corners and do our own little things, those are not going to be the big solutions that are going to move the markets. And that's really what needs to happen to obtain the level of adoption we all want to see.
And also, on top of just your level of collaboration, this is a global effort, right? Like, we are coming from several different nations and working together. Brian, what does it mean to you to have this network of groups that are all, supporting one another?
Right. Yeah. So I think it's to be honest, for me, it's amazing to have this kind of collaborations with other companies and also academias as well. Because you said it's very difficult for companies to work together when they have any competitiveness inside, right? So, but I think for AR, so if it's gonna become a consumer market and a big one, right? So I think there are enough market shares for all the companies to exist and to thrive in different fields. And AR glasses, I think, is very different compared to phones. Because phones, they are giants, they can dominate the market. But AR glasses, they are glasses to start with. So there is a bit of fashion in it. So there are a lot of styling, design, and stuff like that. So glasses existed long before phones, right? So, but there are still so many players in the field who manufactures glasses every day. So I think it's a similar principle that will apply to AR glasses. There will be multiple players, and each of the player will have a unique property to exist. So they will look for different applications, different technologies. So there are a large enough market for all the companies to share. And I think that's why the group can thrive as well at the same time. So Barry brought us together. So we're going to work together to tackle the most difficult technical problems before the laser kicks into the AR display. But I think eventually all of the companies joining the alliance will benefit from the technology evolvement.
We are not all competing here, right? Because
Yes.
we have from the whole spectrum of the ecosystem, we have component suppliers, laser suppliers, MEMS mirror suppliers, system integrators, we have waveguide companies. So we have a really broad range of companies in there. And within each category, we obviously have competition, right? There are multiple waveguide companies as part of these working groups. But in the end, we also have a specific group dedicated to making sure that we define rules and we also handle IP properly across everybody. And but in the end, we need to create a market first, and then we have something to compete for. Yeah.
For the AR Alliance, what are the technical ambitions for this working group? And I think we understand the big picture now a little bit better, but what are the technical innovations specifically that we're hoping to champion and maybe the bottlenecks to overcome to get us there?
The first thing for this group to do is demonstrate that laser has a position. And what that means is at the system level to be able to show good demonstrations to customers, high image quality and a value proposition. And that requires companies to work together to make such demonstrators that are visible to the community. That's surprisingly hard to do, but it's the first step. So once there is actual placement of laser display in the industry, that's going to be one major barrier that's overcome. Then each technology, each particular type of laser display will have its own challenges in order to improve its particular positioning. And those challenges may be different depending upon the different architectures. What you can achieve, what your primary advantages may be different depending upon the different technologies. Some of them would be in common, like managing perception correctly with laser displays, which are different than most normal displays that we're used to, is something that crosses over. Laser speckle is something that crosses over. But not every architecture has a waveguide in it, for example, and not every architecture, a 2D scanning architecture will behave differently than an LCOS architecture, which will behave differently from a holographic architecture. So each one of those technologies will have its own challenges to overcome. But once you have a supply chain and a technology base that exists that is self-supporting, there'll be enough resources to go around, and more resources to go around, and more desire to conquer the bigger challenges, to get to bigger fields of view, higher brightness levels, solving accommodation fully, managing the overall ecosystem.
Love to hear that. I'm very excited to see where this goes. And I think we're approaching that time now where you gentlemen probably have to get on to your next meeting. But in closing, I just want to thank you all for giving me your time and your insight on this topic, on this very exciting emerging field. And we can't wait to see where it evolves to, from both from the photonic standpoint, but just from the consumer standpoint, to see how this, works its way into our lives. And, a big thank you to the AR Alliance for helping make this happen, to SPIE as well for giving us the access. And just we're looking forward to checking in with you gentlemen again and seeing where things go. So thank you so much for giving me your insight.
Thank you.
Thanks.
Thank you.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.